Okay, so hi everyone, my name's Alex and this is going to be my third video in computing tutorials or whatnot, and this one I'm just going to be explaining how to convert binary into simple decimal numbers. Now what we've got here is a 9 binary digit sequence which is all equal to 0 at the moment. We'll change a couple of these to 1 just to show you the conversion powers. But what first I'm going to explain is how do you know what numbers to add to make up a decimal number. So what you have is, when you have a binary sequence of 9, you'll have numbers that are designated to it. So the binary digit on to the most right is equal to 1, and then the second to the most right is equal to 2. Now what this does, it equals to the powers of 2. So this is to the second power, this is to the third power or whatnot, or this is to the second power, this is to the first power, second power, third power, fourth power. And then it keeps on going on and on, so it just keeps on doubling, so you'll end up with 1, 2, 4, 8, 16, 32, 64, 128 and 256. So you know the number on the leftmost will equal 256 in a 9 binary digit sequence. Now to know how to convert the numbers, to convert the binary digit into actual decimal numbers, you need to actually have some binary digits to mess around with. So what I'm going to do is I'm going to swap around the zeros for ones. So I'm going to swap the 16, the power of, is that the power of 4 to 1, and then I'm going to swap the 64 for 1, and then swap the 4 for 1. So hopefully this number won't be too big. So what we do is, if we want to convert it to a decimal number, we take all of the binary digits which are equal to 1 and their designated numbers, and then add them all together. So what we're going to do is we're going to add 64 with 16 and 4. So we're going to have 64 plus 16 plus 4, which equals 84, I believe. Is it? Yeah, I think so, yeah. So now what we do is, since that's equal to 84, we say that 84 in decimal is equal to 0, 0, 1, 0, 1, 0, 1, 0, 0. So we have 1, 0, 1. Yep, so there we go. And just to confirm, I'll go to Google and type in 84 in binary, just to confirm it. Yep, so here we go. We have 0, 1, 0, 1, 0, 1, 0, 0. Now, how I've learnt it at university is just to always have an extra number on the left that makes it 9 bits, but preferably you'd only need 8 bits. It's just the way that I've learnt it means 9 bits, just in case the number gets overboard and gets quite big. But for this you only need 8 bits. And that's what it's equal to. So you have 0, 1, 0, 1, 0, 1, 0, 0. So that's 84 in binary. I'll try it with a bigger number. So I'll move this, and then what could I do? I'll take away, or I'll put 128 as 1. I'll put them as 0, and I'll put 8 as 1 and 2 as 1. So we'll add up 128. So we'll have 128 plus 8 plus 4 plus 2. Quite an easy one really. So we have 128 plus 16 basically. Or is it 14? Oh god, it's 14. So that's 128 plus 14. So that's 30. Is that 142? I hope it is. So we see 0, 1, 0, 0, 0, 1, 1, 1, 0 as 142. We most likely don't need the 9th binary digit, so I'll take that away. So the number on Google might show up as 1000 1110, because that's in 8 bits. So I'll type in 142 in binary into Google. Bear me a minute. So 0, 1. Oh, so you do need it. I think it's anything over 128, I suppose. So we do have 142 equals 0, 1, 0, 0, 0, 1, 1, 1, 0. And that's what we have. So we'll go over again. So it's 0, 1, 0, 0, 0, 1, 1, 1, 0. So there we go. So 0, 1, 0, 0, 0, 1, 1, 1. So that's 142 in binary. And all we did was, we looked at the binary sequence, we looked at the binary digits with the value of 1, and then we looked at the corresponding numbers or powers that are assigned to it. and then we added those powers together. So we have the second power? So 1, this is the 0th power, this is the first power, this is the 3rd, 4th, 5th, 6th, 7th, 8th power. And then so we added together the 8th power, the 4th power, 3rd power and 2nd power, which is 128 plus 8 plus 4 plus 2, which equals 142. And that's all it is really. So binary conversion, if you have a binary sequence, it most likely will be 8 bits. You just look at the powers. It's from the right, it starts 1, then 2, then 4, then 8, then 16, then 32, then 64, then 128. So, and then you look at the binary digits, which are 1 in the sequence you're looking at, and then whichever binary sequence numbers are 1, you add them together with the corresponding powers. So if you add all these together, this will be a gigantic number, I'm guessing. So add all these together and put them all as 1, which I'm just going to Google it because I can't be bothered to work it out. We'll put these all 1. So we'll have 256 plus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 511. Is that what it says? So all of these, when the binary sequence is equal to 1 in 8 bits, it's equal to 511. And that's just in 8 bits. So for the most part, all you do is you just look at the binary sequence, whichever the binary digit sequence is 1, you add those together with the corresponding power that is beneath it. So we'll do this. Shall I do this one or not? So for this one, we have 256, which is equal to 1. So we take that, like the band, and then we see that 64 is 1. So we do plus 64 plus 4 plus 2, which is, so 4 plus 2 is 6. 64 plus 6 is 70. So we have equals 70 plus 256. So we'll add it to our 300, which is 44. So it's 44, and since then we have 26 left. So it's 326, I think. So we'll do, type into Google 256 plus 70. Yeah, 326. 326 in binary. 0. So we have 0, 1, 0, 1, 000, 1, 1, 0. This is what we have. But since we put 9 digits there, we don't really need it. So we just need 8 bits. So take that out, and it's sorted then. So, blimey, it's a bit one. I will explain binary addition next time, and maybe how to convert to do hexadecimal. But for this one, it was just explaining how to convert binary to decimal numbers. I'll put some more info in the description if you don't understand it, which I completely understand, because it's not the easiest thing to explain really, because you just have all these numbers at the bottom and you're thinking, what do I do with these? So yeah, remember, when you're dealing with binary digit sequences, to convert it to a decimal, you only add the numbers where the binary digit sequence is equal to 1. So if all of these are equal to 0, then you don't add them together. An easy one is this one. So since the power of 0 is equal to 1 on the binary sequence digit, and the power of 2, power of 1 is equal to 1 on the binary sequence digit, you only add these two together, which equals 3. So 0, 0, 0, 0, 0, 0, 0, 1, 1 in binary is equal to 3. Oh, blimey, I need a rest. It's like my third video today. I'm sweating. It's pretty hot in England. So I'll put more info in the description. Hopefully you learn something. If not, then just put in the comments what I can do better. Yeah, thanks for watching. See ya. Bye.